Hello and welcome. Today, I am very excited to start analyzing some really cutting-edge dataset that is sent to me by Alejandro, who is my colleague in the Maastricht University, and he is a soon-to-be finishing PhD student. So he's preparing to become a postdoc very soon. So Alejandro reached me out recently and said that he is having some problems registering spiral readout 11.7 Tesla human fMRI data. So this data is coming from France, Neurospin, and Alejandro actually recently published a paper about spiral readout. So he's a spiral readout expert for doing fMRI data collection. So I am very excited to get this data and establish a layer fMRI analysis mini pipeline for it and eventually get some layer profiles out of it. Okay, first I would like to show you a little bit this data set. You can see that this is the EPI data, fMRI data, partial brain coverage. And you can, by the way, this is a new software that I am developing as a part of Laney. It's called Laney EDA. So you can see a link below in the description if you are curious about it. But just want to show you that this is a data set that has 0.7 by 0.7 by 0.8 millimeter resolution. So it's pretty high resolution sub-millimeter fMRI dataset. And nicely, you can already see just by looking at these time courses down on the right, there is some very clear block task-based activity. So in Laney EDA, if I go to this correlations option and I just look around in the visual cortex, I can easily catch some activity. For instance, see this one. So I think everything worked out in this fMRI data acquisition. There is good fMRI signal, activity signal. And if I use very simple block design modeling here in Laney EDA, I can also see that actually there is pretty wide activity. Okay, so let's tackle our problem one by one. So first problem that Alejandro wanted me to help him with was to registering the fMRI data with the anatomical data. Here I put together a simple set of steps that I'm going to mostly use ITKSNAP. So first, I'm going to load the mean of the fMRI EPI time series in ITKSNAP. Okay, see, this is the image. And then I'm going to load the anatomical image on top as additional image. Okay. So here it seems that they are more or less in the same planes, but obviously far away from a good registration. So how can we proceed with it? I know that Alejandro already ran some automatic algorithms and they failed. So I'm not even going to try the things that he already tried, but I'm going to show him a sure way of getting things right. Okay, now, so in ITKSNAP, what I often do is that basically just look at a recognizable brain structure. And for me, a very recognizable brain structure is the inferior and the superior colliculi that you can see there in the back of the brainstem. And obviously, occipital pole is on the right-hand side there. So I'm going to position my cursor and the crosshair like right below the inferior colliculus. So now let's have a look at the anatomical image. The inferior colliculus far away, more in the posterior direction. So I suspect that this is already a translation mismatch most of the way. Okay, so to adjust for it, I go to Tools in ITKSNAP and I click on Image Registration. In the Image Registration menu, I click on the Interactive tool that gives me this wheel, but I don't click on the wheel, I click on the center and then start pulling the anatomical file towards my crosshair. Okay, so more or less I remember that I put the crosshair right below the inferior colliculus. See. Okay, now let's deactivate the interactive tool and let's compare. You can also use brackets on your keyboard to switch back and forth between images in ITKSNAP. And see, it is already much better aligned, just with a bit of manual dragging here and there. Okay, so this is a very good starting point, but obviously we want to do a bit more. So for these partial coverage datasets, what I recommend to do, and since there are obviously strong distortions around the air cavity proximal brain regions, maybe it's better to avoid those regions when you are running an automatic registration algorithm, because obviously it will not match to the nice anatomical image that you acquired using a different protocol. So what I like to do is to go to the brush option, select a large size brush. Let's select 20 for now and make it three-dimensional. Go to my EPI image, that is the source image, and start drawing very roughly my region that has good amount of brain contrast and the region that I would like to really analyze things in. So my activity is basically in this region that I expect. Okay, so once I draw this rough brain mask, what I can do next is to go to the automatic registration menu in ITKSNAP and enable use segmentation as mask from here. And this will only be the rigid transformation. I'm not going to do nonlinear registration for this. Okay, now here I can select coarses level 4x and the finest level 1x. Now let's run this and hope for the best. Okay, you can see that the ITKSNAP is rotating in this way, that way, maybe translating a bit and trying to minimize the cost metric or the image similarity metric. That is the mutual information. And you can see that the metric is going down, so this is good for the registration. And I like to do, actually, once it converges, I like to run it just maybe 1 or 2 more times just to see whether it will go down even further. You see it went down a little bit more. I can do one more time, a bit more, but more or less the numbers you are getting here on the y-axis will be the same, so you don't need to do more. Okay, now let's press S to disable the segmentation labels. And now let's compare the registration quality between the anatomical data and the EPI data. So you can see that things are not exactly in the right position. There's a bit of distortion, but this distortion is expected, right? Because the EPI data has distortions in it from the data acquisition. There are other ways of dealing with it, but for now I will not go into them because I don't have the full data set. Maybe in the future I can help further with regards to that. But more or less we are, I think, in the right spot. Or at least this is a good starting point to run further registration algorithms. However, I noticed that also the brain tissue contrast is not so strong in this dataset. Therefore, running nonlinear registration algorithms on top of it, especially with regards to a T1 weighted anatomical image, might be a bit tricky. You might also end up distorting it more than you want. Another thing to sometimes explore is to maybe expand your segmentation mask a bit more, so that maybe it finds a better registration target and minimize the cost metric a bit further. So let's run it again. So I saw that anatomical image moved a bit here and there. You see it's going down a bit. Okay. Now let's see. Let's judge one more time. Okay, so it definitely like shifted a bit here and there. Okay, but I mean overall it's pretty good to start, and once one is satisfied, you basically go there, and Alejandro maybe investigate this further himself, and you save the registration. Anatomy to functional. So once you are satisfied with the registration and you save the registration file, you can quickly click here, the reslice option. You can choose linear, it's okay. You can also do this outside of ITKSNAP, but now I am showing you the fast or easy way. So you can see that anatomical data is now resliced and sampled in the space of the functional data. Once reslicing is done, you can also save it. Okay, so some of you might wonder why we registered the anatomy on top of the functional data and not, as conventionally done back in the days, functional to the anatomy. There are several reasons to do that, and if you are careful enough, I think either way could be okay, depending on what exactly you do with your data. But I would like to highlight for the curious ones that if you are interested learning more about why we register anatomy on top of the functional and not the functional data on top of the anatomy, there are a couple of papers to read about it and sections of different papers, but maybe you can start from here, from my colleague Shri Kashyap from 2018, the analysis strategies of the cortical depth-dependent fMRI, and this paper includes sections on why one might go about registering the anatomical data on the functional and not functional on the anatomy. So you can read this and make up your mind about it. So that's all for today. This is a short video. I am going to follow up maybe with other steps, depending on the other data that I receive from Alejandro, and hopefully establish a layer analysis pipeline for this really exciting 11.7 Tesla human fMRI data. Thanks for listening, and see you next time.